In this video, we are going to talk about Pandas, how to install and use it. Pandas is an open source library built on top of NumPy. If you are not familiar with NumPy, you can watch previous videos and you can find the link below. It allows you to quickly analyze and prepare data. It excels in efficiency and performance. It also has built-in visualization features and also can work with data from a wide variety of sources. You will need to install Pandas by going to the command line or terminal and using any of the following options. Conda install Pandas if you are using Anaconda distribution, or pip install Pandas. In the following videos, we are going to discuss series, data frame, missing data, group by, merge, join, and concatenation operations, data entry, and output. Now let's learn the basics. Now we'll talk about series, which are similar to NumPy arrays. A series is a one-dimensional labeled array capable of storing any kind of data, integer, string, Python objects, and etc. The difference between NumPy arrays and Pandas series is that series has access indices. Now let's have a look. Let's at first import both NumPy and Pandas. Import NumPy as NP and import Pandas as PD. Now let's create some lists and arrays. My labels equals, for example, A, B, and C, and another list with numbers, integer 5, 6, and 7. Now let's create an array NumPy and pass our list in parentheses. So one will be a Python list and the other one will be a NumPy array. My array equals np.array and in parentheses my list. Now let's create a dictionary. My dict equals curly braces A5 B6 and C7. We have created 4 different objects. Let's have a look. My labels, my list, my array, and also my dict. We have created 4 different objects. Now let's see how we can create a series of pandas. We have to write at first pd.series and then pass the data in brackets. Data equals, for example, my list. Here you can see that I got the series back, which looks pretty similar to the NumPy arrays, but you can really see here that we have indices 0, 1, and 2, and we have data 5, 6, and 7. Here you can specify what you want these indices to be. For example, we can write data equals my list and index equals my labels. And here we add indices, my labels, A, B, and C that we created earlier. When we run this, we will have my labels items, not indexes. You can also simply write without data and index, my list and my labels, and you will get the same answer. But you need to remember that you should write them in the correct order. So at first you should write the data and then index. You can also create series like this. For example, pd.series and in parentheses my array. Here we passed in the NumPy array that was created earlier. We can also add indexes, my labels, and we will have the same answer. And finally, we can write pd.series and create a series with the help of dictionary, my dict. Pandas series can also contain different objects. For example, we can pass in my list as data. A series can also contain strings as data. For example, pt.series, and then we can pass in my labels. And here you can see instead of data, instead of the numbers that we had before, we have now strings A, B, and C. The difference between NumPy arrays and Pandas series is also that a series can hold all kinds of objects as data. Now let's see how we can get the information. Let's create a new series. Let's say S1 equals pd.series, parentheses, and then data 0, 1, 2, and 3. And then apple, banana, let's say cherry, and peach. Here we write some numbers as data and some fruit names as an index. Let's check S1. And here is the result: apple 0, banana 1, cherry 2, and peach 3. Let's make the second series S2 pd.series. Let's put the same data and the indices. Let's copy this one here. But let's change cherry to kiwi. And let's check S2. And here, kiwi 2. If we want to get some information from series, it's very similar to getting information from Python dictionaries. We can simply write S1, then square brackets, and then the index name, for example, apple. And here is the result, 0. We write the name of the series, then index, such as apple, and we get the value, the data back. We can create another series, S3 equals pd.series, and data equals my labels. And from here, we can say the same, S3, the name of the series, square brackets, and index 0. Because here, as you remember, we can check again, S3. Here, indexes were numbers 0, 1, and 2. We can also do some basic operations on the series, like adding. For example, we can write S1 plus S2. It will compare the indices of both and then add values to the data parts. Since we have a banana in both, we will end up with the sum of both, so 2, because banana was 1 in both series. Here, banana 1, and here also banana 1. But since we have cherry in S1 and kiwi in S2, it can apply addition to these two. It will write NaN as data. So when it doesn't find a match, it just writes null. In any operation in the series, your integers will be converted to floats so that no information is lost.